flying saucer.
Okay, this is a little bit smaller motor than the one I showed in previous video. This is from a drill, and this has his symmetric version right here. I just used what I call linear brushes, because they are not following they are straight, and you can see it right here. And by the way, this is the type of brush that I was referring to, that it's kind of reddish in color, and it's very good, high quality. You can see the metallic look in it, and it's very solid. It's not like the fading carbon type soft. This is very hard, pretty hard. And anyways, what I have done here, I have set channel 1 and channel 2 to the in the scope, and I have set also, it's at 1 millisecond, and I have set V-top in blue and V-top in yellow, channel 1 and channel 2. And what I'm doing is I have connected the output is blue, and the input is the yellow channel. Now the power source is set up at the same type that I did. I have set current max, current to limit, and voltage to limit. It's an 18 volt 3 amps power supply, and I'm gonna be running it and checking the scope measurements on this, and this is linear again. This goes negative, positive and negative here. And this motor is being wound with 30 gauge, the red Radio Shack motor, and you can see there V-top is over, every square is 100 volts, so it's going over the ridge over 300 volts, which is 288 300. Now if we go in time, millisecond, we can see the difference in output of this motor right there, and it's at 69, 70, and temperature on this, it's very low temperature. This is room temperature, 87 degrees, 88. It's only about 1-2 degrees above. And the speed is, well, really hot. And pretty steady too. Now, you can see the obvious increase in power. Now it's at 500, 100. Let me set it at 150, 100. You can see right there the very high increase, and the spikes are they're not random. They are very steady on the positive side of the line. The positive spikes, and you can see the readouts there. Now that's what used to be our back EMF. We're collecting it right here. And the strength of this motor, it's see the amperage goes, I'm grinding and I don't want to do that. So you can see there the output here. Now what I'm gonna be doing, it's I'm gonna be checking on this motor here. This is a symmetric motor. I'm just going to be, I'm not going to scope this. Most of you guys can do that. Just going to add this, and you guys are going to see these motors symmetry. It's you can reach very high RPMs, but then you have to sacrifice torque. So this motor right here is it can reach high RPM, it don't, and if I keep it like this, it won't do it. It won't do a hole on here. It will get stuck and amperage won't drop down. It gets high speed, but it doesn't have the torque, and I am not even pressing it that hard. That's the reason why they need to connect these symmetric systems into these complex gearboxes, so they can amplify the torque by a very sophisticated gear transmission system that they use it on impact drills, and that's how they can make it. Now this motor, the problem with this motor is it gets stuck for a certain amount of time above the 3 amps or 4-6 amps. It'll burn out. It'll crispy fry. So here I have the same motor. I have attached the drill bit on it. It kind of vibrates because this is not the proper chuck to hold it steady, and it kind of oscillates a little bit, but it's so you guys have an idea and watch the amperage, what would using a direct straight motor with the drill bit. Watch this. It's going through, and watch the amperage. It doesn't stop. Okay. It passes the whole thing. This is asymmetry.